Actually, the hardest blade I've made was Orcrist.
Yeah.
Because that was massively wide. It wasn't as long as those blades, but it was just such a massive lump of steel. Imagine that when it's a lump of steel, full width, full thickness, no weight removed. It was hard work.
All right, today, I'm really excited about today because I get to play and learn from my old friend and sword teacher, Peter Lyon.
Your Sifu.
My Sifu. He is Weta's sword master. Last time he helped me make a Strider-inspired sword out of aluminum. This time we're making a hero prop for our production.
That's right. It's actually used for filming, and it's going to be a dagger. This is the dagger that our soldier in the beginning of the film will use. You will take from him to kill the creature. So you can see close-ups, you can see in action, which means not just one version of this.
Yeah, and Peter often makes swords, hero swords out of steel, stunt swords out of aluminum, and then they cast others out of other urethanes and rubbers. My Strider-inspired sword I made a couple of years ago was aluminum. This time he's teaching me how to grind this one out of steel. So I'm going to learn a whole set of new techniques, I think.
His shop is a happy place for you. Let's head over there right now.
Okay. Hello, sir.
Welcome back, Adam.
Good to see you, Peter. How are you?
Good.
Thanks for helping us out on this project. We're going to be building a knife together, a dagger.
Yep. Now, last time, of course, we made an aluminium blade or aluminum.
Yeah.
For your hilt. So this time, I was thinking, make a steel-bladed dagger with some bronze components and everything else.
Oh, very cool.
But because, of course, we're pretty tight for time, keep it small.
Just keep it small, keep it easy to make within a period of time.
Yes.
Okay.
Yeah.
What are you thinking of in terms of the what it looks like? You've got some sketches here.
Okay. So this was just roughing out for getting materials. We've got a scabbard.
Okay.
So essentially we'll make a blade that fits that, so about that long for the blade.
Right.
Got a sketch here for a sort of a generic medieval style cross guard. So I've got a lump of bronze there. Usual story, some assembly required. We have a grip, which we should be getting back soon, hopefully, which is already, it's a reused from another project.
Oh, okay, great. So we're
So that saves that piece of work, and we have another lump of bronze for making a mushroom type pommel out of. That would work out really nicely for an oval section. Do you want to do some steel grinding?
I do.
Okay. Have you done much of that in the last year?
No, I've done a lot more aluminum grinding in the last year, but no steel grinding.
Okay. Well, what you'll find is that steel is both harder and easier. It's a harder material, so you'll know with aluminium that you can just be going along and suddenly you've gone too far.
Yes.
Because it's like butter.
Yeah.
So with steel, you can work it harder, but not run the risk of messing it up in a single pass.
So the cost of failure is lower, or not the cost of failure,
the risk
but
is
the cost
lower.
of inattention, perhaps.
Yes. Yeah. So you tend to get a second chance.
Okay.
Now, because we're talking here about a prop for filming, there are certain little cheats, if you want to call them that we can use. So imagine that here's your dagger blade, probably around about that size. Normally you would make a tang that goes right through the cross guard and everything else. So now normally what would happen is I'd make a tang as wide as possible without making the grip too weak.
Right.
And then when it comes in through the pommel, taper it down so that as it comes through the top of the pommel, it's just basically a stub like that. Then heat it and mush it down to a mushroom. And another little trick I've learned is that particularly when you're hammering against a softer material like bronze, it's very easy that is still spring steel, of course. You reach a point where you hammer it down, but as it cools, it just won't move anymore. So what I've learned to do is put a welder stub of mild steel on there, and then it can also be worked cold once you've done the basic forming of that. Now, we can do that, or we can do another little cheat, which would be, imagine that's the pommel, that we stop the tang somewhere inside the pommel. We have some drilled holes, and we cheat that with a rivet. This would be glued.
Okay.
Yep. So plenty strong enough for what we need. This would be the correct period way of doing it, but it's a little fiddlier and means a bit more playing around.
Time is tight, so I think we're going to want to go with the faster method.
Yep.
Now, you asked if I wanted to do some steel grinding. I definitely want to do some steel grinding, but I also think it's important that I try to do some of this shaping, because I haven't tried that at all before. We didn't do that the last time.
Yep, bronze is really nice to work.
Is it really?
Yep. So I can't remember what type of bronze these are, but typically I like using something like LG2, which is a machining bronze, and it's made for milling, but it also grinds really well.
Ah, okay.
And keep a bucket of water handy because it's copper based.
So it transmits heat really
well.
You want gloves,
Yep.
heavy gloves.
Yep, and
Okay.
yes, you'll still probably cook your fingers.
Okay, that's fine. I'm used to that.
So I've just done some quick numbers of what a reasonable size little dagger would be.
So if this is 39 wide, then that's
Yes.
probably working against one of the flat edges.
Yep, and the other thing I learned was certain swords, like if a sword has a taper, you can get 2 out of 1 length of steel sometimes, but with something like this, it's easier just to mark a center line, and because at least then when you're holding it, your center line is between your fingers.
Ah, I see.
Whereas if you run it off center, you've actually then got to keep adjusting.
Oh, so I should then just do the center line of this, is what you're saying?
Yep. Because the order that we do this in, sometimes it makes your life easier and sometimes it makes it harder. You may want to cut the tang out because it actually creates quite a useful handle. But do the fuller first, then cut the profile of the blade, then grind the edges roughly before heat treat.
And I'm assuming this means it goes from 15 to 12?
Yep, that's right. Maybe even make it 16 to 12. Again, we can make it a little bit narrower to suit the grip we have. But if things are a bit sloppy, then we start doing things like little wooden shims and things like that that can get a little bit tedious.
39 wide. Does the fuller travel straight to a point, or does it?
I think make the fuller parallel till it gets to maybe here and then curve it in.
Oh, okay.
And so we'll do that by doing a pretty parallel grind and then scoop it up.
Okay.
So
Maybe right to about here, you said?
Yep.
Okay.
So I think the curvature of the edges will help to refine the fuller and give it a nice narrowing as it gets towards the end. What you want is basically each pass, the curve of that contact wheel sits in the exact same groove, but by following the lines, what often happens is you get this sort of double bite effect.
Right.
So that you get a little line of a ridge in the middle where the two, instead of getting one curve like that, you get 2 curves that happen to meet.
I encountered that problem.
Yeah. And the only way to get around that is lots and lots of practice. Yeah, that'll make it look a little bit more refined.
Oh, that is much more refined, yeah.
Daggers like this weren't about cleaving people, they were finding the little gaps and going, ick.
Right.
So in all your time doing film work, did you ever make knives and swords for any productions?
Yes, no, I did. I made some swords for some Shakespeare production.
Yep.
They had a budget of $20 per sword. So I took.
So that covers materials.
I took some wooden slats and on a belt sander made them look roughly blade-like, and cut them out like this with a tang.
Yep.
And I covered them. I made them smooth and covered them with aluminum tape. Those were the swords that I made.
Yep. I've heard stories. It's pretty much how some TV productions still do things.
It was
For backgrounds.
It was very. It was. I was impressed with how good they looked on stage. The actors definitely really liked that. Yeah, $20 per. That was a standard budgetary problem back then. All right, so I have a fuller mark out on both sides.
Right. Yep. Because of the way this is going to be done with the cross guard sitting right up to there, and in fact being on a point, it will come down a little bit over there. The ideal is grind the fuller up to there.
All the way to that, okay.
Yeah. And then it is a little tricky, especially with a short fuller, because what you want to do is to grind. So here's the width of your contact wheel. So you do a grind and you kick it up there as so essentially this trailing edge of the contact wheel runs up
to that center
point. And with a little bit of practice, you'll just get your angles so that it's contacting as it's pulling out, and you get these lines hopefully coming along pretty well without having this little chatter that can easily happen.
Got it.
Up here, because the middle of the contact wheel is grinding all the way up to there, If you just stop there, you'll have less grinding up here because you're immediately moving back, and it's had less grinding time. So the other little trick is when you get to this end is to turn that into the contact wheel a bit so that that corner presses against the edge of the contact wheel. Okay. So the belt removes material at a fairly even rate.
Right.
But because of the width of the contact wheel, if you come up to here and then immediately start moving back, you'll have less time with this in contact with the belt than this bit.
Then the rest of
because yeah, you get to here, you keep going, and if you just keep the same angle, this end will end up shallower. So there's this little trick of, as you're grinding and you come into this corner, turn that in a little bit so that there's a bit more pressure and a bit more time in that
more
corner.
Here, and then it comes back. So
yep, and then you rotate it back.
That makes total
sense. As you come along. So it's going to be this sort of movement. So starting there, it's going to be turning it in, rotate it till it runs along flat, and then do that. So this is one of those muscle memory things where you're doing a movement like this and just finessing at each pass. Do you want to start on steel?
Yeah, let's do it.
Okay, now, next thing is what size contact wheel will give the depth that you want?
This strikes me as I want a very small contact wheel.
So, and this is 6mm thick steel. So if we aim for about 2mm deep each side, we'll get a really well-defined fuller with nice crisp shoulders where it transitions across to the edge.
Okay.
So it's a matter of just going through my box of
working out that curve.
Now there is a little trick, there's a trick for everything, of course, but a little trick for this one is to literally find a contact wheel. Let's say start with this one.
Oh, I see what you're talking about.
Quite literally get it up to the edge of a table, trace the curve. And since we know that the fuller is 16mm wide, there's the surface of our steel, there's the depth that will cut, and that is a little over 2mm. Right, this belt has a bit of life in it, but it's not so fresh that it's going to leave deep gouges. So this is probably a good starting point. So do you want me to do a couple of passes and show you what I was talking about in terms of the movement, and then hand over to you?
All right, yeah, by all means. And you're not going to have a bottom on this?
No.
All right.
Do you want one?
I'm willing to try with that.
Okay. So first thing is get it tracking properly. So stand out a line from the belt.
Yep.
If these belts are going to break, it's usually when they start up. So it's not tracking properly, so I'll wind it across a bit. I'll do it that way. So the movement I was talking about was, say I start up here, I start with it angled that way, and then as I get to this end, I start pressing this corner in, so that it's doing as much work there as it is there. Got it. Let's just have a look. Oh, and I always start a little bit short of that, because once you've got a groove, you can start extending the groove. It's quite easy. Groove is centered. There's the start of a fuller. All right. You can see it's still pretty wobbly. Yep. And so each successive pass, you just refine that a bit. Okay. Until you're just about to touch the line, pretty much. So you've got a very good line there. Yeah. I think you're turning the point, scooping a little early. I am. So you can cut deeper up to there and then start scooping up. Copy that. And just a little bit more pressure up there. Cool. And when you get to a point where you don't want to risk running over the line, we can switch to a finer grit belt, and then you can keep working it just a bit more slowly. Oh, okay. Okay, cool. Yep. think swap to the other side now. If the fullers end up a fraction short, that's not a big deal.
Okay.
This next step I'll do because I can do this quickly, and it's a technique that I wouldn't recommend to most people.
Okay.
I've been doing it this way for 30 years on long straight cuts, but it's not something that I'd recommend for anyone learning.
Okay. I trust you on that one. Show me.
Okay, so
Wow.
So it's quick,
Yep.
messy, noisy, but quick.
Yes.
And at the end of this, we just get in there and quickly remove all the nasty burrs and things. And we've got all our cuts done. Oh, that easy. That's all there is to it. The next thing will be just tidy up all these
Oh, right,
cuts.
right.
The other thing is for those straight lines, you could also run it that way if that feels
Right.
Get it? Ah. So it just barely crosses the shoulder, and then it'll follow that curve into the point. Yeah, what will probably happen is that you'll end up bringing the run out of the fuller to there.
Oh, okay.
But again, it never hurts to be a little conservative with your first grinds. The main reason for doing this before heat treating is that you remove the bulk of the material. So then the heat treatment works better because it can draw the heat out quicker, that you're not trying to draw out of a thick section, you're trying to draw out of thin edges in particular. If it all comes out without any warpage after the heat treat, then the final grinds are reasonably easy. Well, the Western style of heat treating is a two-step process. So the first step is you get it up to heat, which for steel like this is usually a reddish orange colour heat. Then you quench it in oil. That sucks the heat out really quickly. And essentially what that's doing is it's freezing the steel.
The molecular, right.
Yeah, it's freezing the steel in a very hard crystalline structure. But that's not too good because it's great for edge holding, but it makes for a blade that can snap. So the second step is that you take it up to a lower heat and draw out some of that brittleness and get a combination of hardness and toughness. And trying to figure out what the blend is, what's your ideal point of hardness and toughness.
I see. Right.
Yeah.
And I don't know between flexibility and the ability to hold the edge.
Yes.
Right.
Yep. Because if you have a really hard steel, it'll hold a brilliant edge, but you'll probably snap the blade at some point.
The first time Yeah.
And sooner or later you'll lever something with the blade, and then you'll find out if it's too hard.
As I have many times in my life. Once more into the breach.
Yep.
I don't have any major disasters yet.
Yep. You reach a certain point where you want to work that side, do the same thing on that side, and then you'll see how thick the edge is getting.
Oh, okay.
The thing that I always used to do and still have to watch out for is that I can overgrind the first side.
Yeah.
So then when I grind the second side, I realise that the edge isn't going to be in the centre.
Right.
So you're stopping a little short, do the other side, and then you just start.
And do I want to, is this a reasonable place to stop here before trying to detail this top part?
Yep, that's a good place to stop.
Okay.
The other thing you could do is, as you come into here, turn it and cut in with the end of the contact wheel, and then cut from this end, you can cut that piece as well, coming in from that end. But yeah, it's going well. We've got a bit of day left, so let's do the heat treat.
All right.
So what I've got is a vertical tube of oil.
Is what?
A tube of oil. It's vertical.
Right.
And that's for long sword blades. So this could be done in a flat bath probably, but I've got a tube, so we get this to an orange heat, put it in the oil, hold it for about 40 seconds, then pull it out.
Okay.
And wipe off the oil. That will have hardened it. And here's a little trick. By pulling it out after 40 seconds, instead of leaving it in there a couple of minutes, the transition of the crystalline state is still happening. So not so much with this, but when I've got a long blade, I pull it out and the blade might be like this. But I've got about 60 seconds where I can get that blade on the table and be working kinks out and get it straight again.
No way.
Or near enough that I don't have too much straightening to do later.
Crazy.
But if you do that for too long and it's fully hardened up, you run the risk of snapping the blade, because then it's all very, very hard.
Right. Oh my God.
But with this, it's going to be so easy because this is short and stiff and thick, so it shouldn't move.
All right.
So heat it, quench it, clean it up, get rid of the scale because we need a clean surface to then see what happens in the second stage. And the second stage is gently running a gas torch across it, and we watch the color transitions. So for example, you see there's a blue, grey, blue, and a little bit of brown.
Yeah.
So the brown is the coolest. The blue is actually generally a good color for most spring steels, because it means that you've got something that will still hold a good edge. But, but it is now no longer brittle.
Right.
And you can make it softer with a shorter blade like this. Generally you'd want a hard edge, but as a film prop, we're not too fussed about that.
Yeah.
So basically it's just keep working it with a flame. You want it to take 5 or 10 minutes. You don't want it to happen too quickly, because again, it's another crystalline state change, and that takes time. So gradually bring it up to heat. Let the whole thickness of the metal heat, get it up to the right color, and that's it.
All right. That's the oil.
That's the oil.
Oh, okay.
Believe it or not, it's canola.
Really?
Yeah. I researched oils when I had to replace my old machine oil.
Yeah.
And what I found was that machine oils, that they behave differently. Machine oils and vegetable oils behave differently. It's to do with how quickly it sucks the heat out. Machine oils are better at that, but what happens is that you get cavitation, which is where you're boiling the oil off the surface.
So it's not even touching it.
So you've actually created a vapor layer for a few tenths of a second until that collapses. And canola oil actually performs better.
Oh.
So it's not this is a slightly brutal way of doing it, but it's quick. Trying to make sure that both sides heat evenly.
Otherwise you could end up curving it?
Yep. And it will take a wee while before you start seeing any glow. Start seeing the colours coming through.
Yep. I see the brown and the blue.
Yep. That would actually be a little bit too soft already, if that was a temper. I always pause a little bit there because the rest of the tang acts as a heat sink.
Right.
Oh, it's getting hot already.
I can see it starting at the beginning of a glow.
Yep. It's all about BTUs. Pumping the heat in. It's getting close. See the curve?
Oh yeah.
Yeah. Heating too much from one side. Hopefully it straightens itself in a moment. Not so much. I'll just see what it does when it's up to heat. I might have to actually tap it straight. So when I'm ready, I'll pass the torch to you. And it'll be good if you, I'll quench this, but I'll pass the torch, and it'll be good if you could turn it off.
Oh, copy, no problem.
And there you go.
Got it.
Good. So there was a brief flash of flame. That's normal. Because the surface of the blade was above the ignition temperature of the oil.
Right.
And then as soon as it cooled off a bit, it stopped burning.
Smells good too.
Yep. Side benefit. Much better than machine oil. That's probably about 40 seconds. Let's see. Slight curve. Ideally, clean the scale off before it gets cold. It just means that there's less chance of spontaneous cracks forming.
I see.
Not very likely, but always a possibility. We've got that contact wheel for the fuller, 4-inch for that, and for those surfaces.
All right, I'll do it.
Yep. Okay, so I've changed the torch tip, so now I've got a very small tip. What I'm trying to do is put a small amount of heat in for a while, and then get it to modify its crystal state again, so it's a lot tougher but less brittle. And so the best thing is not to hurry this, so I use a gentle flame and just slowly warm up the whole blade and look for colour changes. I'm working mostly in the middle of the blade because what I want to happen is for the ridge lines along here and the fuller to get it to a slightly softer state than the edges, and for the heat to just work its way out.
So you're not trying to get the edges to that heat.
No, I mean, in a perfect world, a knife will have slightly harder edges than centre.
Yeah.
And this may achieve it. Sometimes the heat bleeds out a bit much, and the edges get a bit softer than I'd like. But again, on this dagger, it doesn't matter. But it's just nice to see what can be achieved.
Yeah.
Now you just start seeing that brown straw colour just starting to appear.
Yeah, I see it.
I see those colours, I avoid those areas, and I start moving the flame faster over areas that are already colouring.
Look at that.
So all going well, everything gets up to a similar heat at about the same time. Need a bit more time there.
Yeah.
There's more material.
Look at that. Look at that. It's so pretty.
Again, I'm used to sword blades that have more material, so they tend to take longer to get here. In fact, I think that's already there. A little soft actually, but that's not a big problem. And I'll just keep the heat going up the tang and just make sure that the whole tang is softened a bit.
So cool.
And that's that.
Amazing.
Now just let it cool and come back to finishing it.
Tomorrow morning.
Yeah.
All right, Emmett, how are we going to do this?
So we are going to mix our goo, and this is CC60. It actually comes from the mining industry in Australia, a chemical factory over there. So
what is it used for in the mining industry?
I think they make rollers and conveyor belts and stuff with it.
Oh, okay.
It's very resilient, and it works really well for weapons.
So since this is a stunt dagger, are we giving it some structure inside?
Yeah, we will use an armature which I made out of 2 hacksaw blades.
Hacksaw blades, that's so cool.
Yeah, it's because it's very thin here, we haven't got much room, so it's about more like a think of. Usually we use something thicker,
right? Maybe
some 4mm spring steel rod or
I see.
6mm, but we just don't have the room for that.
All right.
And it's such a small thing.
So this is really cool. This is clearly made for production to be able to turn weapons out. This is your guys' shop system for doing this?
Yeah, we've developed this between the mold shop and us. We've worked hard trialing and erroring over the years, and we've come up with this system, and it's like the hydraulic excess fluid sort of just pours out here, which you need that sort of, in order to get a decent seam, you need to be able to get rid of that excess quite quickly. Just a clamp system. It's nice and easy to deal with in a quick, repetitive way.
Let's do it.
Yeah.
Is that enough for the whole knife?
No, it's just for one side. So we do one side first, then we'll do the other side, the lower side. Love that smell, right?
I need a certain amount of it in my system, right?
Okay. You want to pour that into this side.
Into this side.
This is our lid.
All right.
And then what we'll do is we'll pour a little bit in. That'll be about enough. And then we want to give that a decent skin.
Okay. Oh, like spread it all around inside?
Yeah, that's right. And it breaks all the surface tension and all the bubbles and stuff, and so you don't get any little bubbles. You gotta, really get your fingers in there. And now we can pour a little bit more in there.
And you can go excess because it'll squeeze out.
Yeah, just for this side, yeah. And then we want to, once it tacks off a wee bit, we want to drop the armature into that. If you put it in
too early, it'll sink through.
That's right, sink through. And if you put it too late, it won't bind to itself when you pour it in.
All right.
Now, what I usually do is I will go in and I'll just clean up the edges here. Mm-hmm. And that just gives it a really nice seal.
Oh, nice.
Because if this does start tacking off, it'll make it thicker and you'll get a thick seam there. And thick seam means more cleanup, and that means more money. So we don't need that.
So everything about the system has been geared towards fast turnarounds, fast cleanup. Yeah,
fast cleanup. I mean, if we take the time and do it here, then cleanup can spend less money, less time, and there's less wastage on that side.
Yeah.
You can probably dump it in now.
All right. And where?
So we want to bring it up to about up to here.
All right.
So if it's too close to the tip, that's perfect.
So this isn't a hard plastic resin. This is like a hard rubber.
It's 60D, so it is reasonably hard. Yeah.
What would it be equivalent to? And something I might. It's harder than like a spatula for cooking.
Yes, it is. Yeah, and it's you wouldn't have anything silicone that hard.
Yeah.
But maybe a spatula that you might put plaster on a wall with.
Oh, okay. Yeah. Mm-hmm.
So I'll give you that.
Okay.
And we'll do the same again.
Just a little bit and then work it through?
Yeah, that's the one. Yeah, it's going off quick. It's a hot day too, so it's going off real quick. Now what I'll do, while you're doing that, I'll just relay this side up. And that's just to give this side a bit more, just to keep the previous side from going off too quick.
Mm-hmm. All right, now I put more in?
Yeah, put the rest of that in.
All right.
Perfect. Now, what I'll do is, you want to tip it on?
Yeah. Which goes on?
So this goes on there.
Okay.
That's the one. Now we do these up.
Woo.
Perfect.
That was scary.
Yeah, I know, right? You get into it pretty quickly. You get a flick going.
All right, so now we wait.
Yep.
Okay.
So that's about half an hour.
Okay, cool.
Or we can stick it in the oven. It's about 20 minutes.
Let's stick it in the oven.
Yeah, let's do that. I love my job. We're pretty much problem solvers.
Yeah.
That's, I think, if you love puzzles, you love to solve things, this is the best job for you.
Yeah.
Great. I love it so much.
How many castings will that silicone, you use that for weapons, for like movies where you're doing hundreds of weapons, how many castings will a single mold last for?
Around about, because we like to warm up our molds, so it doesn't, it takes the integrity of the silicone out. So perhaps about 30 times. We sort of aim for about 30 repos.
Yeah. Is this the stuff that we just cast in?
Yeah, exactly.
You're right. Okay. Yeah. So it's like you can't really get hurt with it. Well, you could actually cause some damage.
Yeah. Our stunt soft ones
are even softer.
Yeah. We tend to use foam or a really soft elastomer, and then back that in with foam.
That is really cool.
Yeah. The feature that we're on at the moment, which I can't tell you, but we're doing a lot of weapons for that, and so there's I think there's about 4,000 weapons.
Wow, so, 4,000.
Yeah, there's a lot, and so you can imagine that one little process that we just did then, and there's 30 casts from that one that we can get from that one mold.
So you've got a whole team just making molds.
Yeah.
To support the iterative castings.
The crazy amount of casting, yeah.
And how many castings are you able to get out of a mold in a day? 10 or 15?
If you're going flat out, yeah. probably 10 or 15.
So then each mold doesn't even last necessarily a week.
Yeah, that's right.
Wow.
You can burn through them really quick. And especially when you go, so you want to do your hard weapons first, and then your stunt soft ones, because then you start using foams, and foams really eat into the silicon.
Okay.
You might, if you're doing straight foam, you may only get 20 casts before it pulls all the detail out of the silicon.
Wow, wow.
So we always do that at the end of the life of the mold, yeah.
4,000. That makes me tired just hearing that number.
Yeah, yeah. We've had over 15 people just in this one area alone, and just churning it out day in, day out.
Hey!
Look at that.
That looks beautiful.
No touchdowns either. This side.
No touch. Oh, that means the
armature
did not get to the surface.
hasn't come through yet. So it's still pretty
soft.
pretty green, yeah.
So you don't want to pull it out yet? Or
I think we might let that cure just a little bit more.
All right. God, it's gorgeous. The detail's wonderful.
Once we demold it like this, we'll put it back in the oven, and then we'll bake it out for another 5 hours at 70 degrees, and that'll post-cure it.
I see.
And
Right.
Then there'll be no product kind of leaching through into the paint or anything like that. It's not going to gas off and cause bubbles under paint or anything. So.
Well, all right. I'm going to leave you to baking this out. Emmett, thanks very much, sir.
Thanks very much.
Cheers. Day 2 of working in Peter Lyon's shop. Yesterday was very productive. We got most of the blade fleshed out and actually heat treated. Now we do finishing on the blade, and we do the guard, grip, and pommel. And I have to say, it's lovely that Peter insisted we do this blade out of steel. Last time I was here, he taught me how to grind a blade in aluminum. Steel is a very different material, obviously, but the way that it moves and the way that it gets formed is also different. And it was lovely getting Peter's instruction and even watching him do some of the grinding to see how that difference actually fleshes out. Pun intended, as to how the knife responds to the grinder. So once more into the breach. All right, Peter, our blade is moving along nicely. Yep. What are the next steps?
Okay. Well, while you were away, I actually went forward a little bit. So I've slimmed down the tang.
Okay.
And slimmed down the edge of the blade a bit.
So it fits in the scabbard.
Yep. So now we know with a little bit more grinding, when it's finished, it should slide in there nicely.
Brilliant.
Hopefully you can get it out again, because the problem with a leather scabbard is you grip the scabbard to pull it out, and of course what you're doing is
you're holding it in. Yeah.
Okay. And that's our grip. So it almost fits where we want it, and it's reasonably snug.
Oh, now we've got the bronze that makes the guard and the pommel.
The pommel, yep. So we've got lumps. Now, if we were to just grind this out and then fit it to the tang, if our drill holes are off at all, we find that suddenly our crossguard goes like that.
That's no good.
Which is no good. So I start with a bigger lump like this. It's a little oversized. So we mark where we would like the alignment to go. We drill it out, file it, get it fitting, and then if the alignment is off a little bit, well, we just mark a new center and we work off that.
So we start with it on the blade before we even mark it out.
Yeah, that's right. And the same with the pommel. And in this case, the tang is over length for what we want. So there's about the size we're after. So in this case, we'll drill into the pommel but not right through it. And then that trick that I mentioned before about cheating it by using a rivet
on the
to
other
look
end.
like that's the end of the tang going through that's been riveted over.
Okay.
And doing that saves us a bit of work.
When we drill this, is this on a milling machine, or are we drilling several holes and then filing in between and taking them out?
We drill the basic holes on a drill press.
Okay.
If I grab there's a pen.
Yeah.
There is a little trick to this, like every process. There are tricks. So the trick is, say there's your final slot. First thing is drill to that size.
Yep.
Because we know that tang is about 6 millimeters thick, we don't drill 6 millimeter holes, because when you file it out, it always gets bigger. And if any of these holes are slightly offline, it can only get bigger.
I see. And you don't want it rattling around.
So we start with, say, a 5.5 drill bit.
Okay.
start with pilot holes, then we drill the full-size holes so they overlap slightly, like that. And what happens is that we're breaking through from each hole into the next, but we've got a guide hole so that the drill dust doesn't pop across.
Ah, okay.
Yeah.
I see.
So yeah, so say that's 5.5. Maybe we start with a 3mm guide hole. That it's a little bit fiddlier to set up, but
right. But and that's on a 2.75 center to accommodate, right? So you know, right.
Yeah. So we've got to work out how many holes we need. I suspect we'll only need 2, 3 at most, but we do that. And then using a drill, a handheld drill, punching through sideways to remove most of the webbing. And all that you've got left is this little rough surface, ideally, and then a bit of file work should get it fitting.
That pilot hole trick is really cool. It hadn't occurred to me. I've done slots like this before, but I hadn't done them with the pilot holes.
The machinist approach would be you get an end cutter and you go.
But not everyone has a mill.
No.
Okay.
And this is stuff that I started doing 30 years ago when I had no real equipment available. So I used what I had, and it still works well.
18.65. So.
Or the old trick is eyeball it. Well, we know that this isn't going to hold anyway.
Ah, that's right. We're going to be we're oversized.
So really quick and easy way of doing a rough center.
Indeed. Okay, and then what I'm saying is correct. It's 8mm, 4mm on either side. So I've got the 3 pilot holes marked.
Yep.
And that should give us, that should get us very close to the outside width of this.
Even if the hole ends up a little bit wider, because they're rounded corners, we can just file enough that it fits nicely because it's going onto a tang that's more or less rectangular.
Right. Okay, so 3mm and a 5.5mm?
Yep.
What a beautiful center punch. Who makes this center punch?
I don't even remember where I got that. That pilot hole will help because you've got something that will guide the drill bit through the center.
Right.
Even though that center hole isn't usable as is. Hopefully that hole ends up wide enough. If not, we can, again, get a drill and hold the drill at an angle and just let it selectively cut away the edge as it goes through.
Okay.
Because of course, you know the nature of drill bits is they always want to pop back to the center.
Yeah.
But if you force it in and hold it at just the right pressure, it will work its way through while shaving the side.
Yeah.
And even if it's rough, it's good enough for this exercise.
Exactly.
And it grips the glue.
Okay, so you have a battery drill?
I do.
Slowly making progress. You might think that filing takes a long time, but it happens faster than you think it will. That's the lesson I'm learning in my older life. How much work you can get done precisely filing something into form. It's faster than I always think it's going to be.
And it's a lot faster than doing the whole thing again.
Yeah. That is really good. All right, so I'm going to round the edges of the opening there.
That's plenty close enough for now.
All right.
We can refine that because now you've got it so close that you can see what your alignment is.
Exactly.
Mark your new center line.
And then cut to that.
Yeah. And then later on when the final fitting happens, because that's not quite where it's going to fit, it's got to come down a little further yet.
Right.
Because of the point that's going to be ground into it is actually probably going to end up about where the fullers finish.
Okay.
So the final fit will be a little bit further down.
Right.
But we can leave that until we've got it rough shaped.
Perfect. Okay, so now we want to align the new alignment here.
So it's fitting near enough now. So final fitting can wait till later. So this is the sort of shape we're looking at. So the long side is your plan view, and that's your top view.
Okay.
So a nice shape that appears a lot in swords and daggers in the Middle Ages is this sort of curve to a thin waist, comes out to a full thickness bulge, which also will match roughly the width of that.
Ah, yes.
So you see how the curves will come up, bridge over there, and then come down to a waist, and then widen out to an end. And the final finish on the ends will just be little squaring off, which could be done with files or machines. But, but the basic shape would be leave that full thickness there, because it's already about right, and work out how thick, how wide you want it at the ends and in the waist, and just draw lines that look nice.
All right, I will do.
Now, I had originally thought of having a washer there, but I think it might be easier just to make that come up a little higher.
In the interest of time. Yeah.
Yes. Okay, and a final width of about 90 millimeters. Let's just have a quick look. Is that about 90? Yep, it's pretty much on the numbers. And you can keep it fairly rough at the moment. Later on, when you've got all your sections roughed out, you can start seeing where the proportions work. Trying to get it perfect in the first pass often means that you can go too far and realise that maybe it's, you should have left it a little bit finer.
Right. I see what you mean. And give yourself room to move. So I could even pull back a lot of this stuff.
Yep.
And then
the final thickness could even end up close to that
being
line.
that, right. So that
But it never hurts to leave it a bit on the bulky side at the moment.
And then come out slightly.
Very, very slightly. So
like there.
Yeah. So much finer at the tip than that. I thin it down by that much, turn those 8 faces into an oval, and that gives a starting point for marking a line around there, and then I'll just turn the top into an even curve, and the underside will be a hollow ground that just goes all the way round, following a reference line there, which I'll take off the grip, and the line of do not cross.
The farther you grind in, the faster it heats up.
It feels like it could be a little bit thinner through there. Though again, when you get down to the final stages where there isn't much material left through that waist, it'll be very easy to reduce it.
Yeah. Well, I feel like I also want to move to a smaller wheel.
Close to lined up. And probably later on, when you've got most of the bulking done, you can just eye it up and just figure out what's what.
Yeah,
and also the blade itself isn't final ground yet either.
Right.
Still all the edges to do, so I could play with the edge alignment a little bit so that if it's canted off by a couple of degrees, I can preferentially grind the blade to hide that. Again, none of that will probably show up on camera, but it's nice to know it's there. Just looking at this, I think the centre line through there is probably about the centre of that. Oh, also I think that's wider than it needs to be.
Oh, yes, so you're totally right.
No, actually it's pretty close.
It's really
because
close.
that makes up for the washer that's not needed anymore. Getting close.
Yeah, I'm very pleased. And you're flat edge to do those a little better. But we have these are all the parts that we've been making, and you did some final shaping.
Yep, and shined them up, so it's actually as new now.
Absolutely gorgeous.
Yeah, so we can quickly pop it together.
Okay.
And just see how it all goes. Everything aligns as one way, because handmade, of course.
I see you've got little
Yep.
marks.
Yeah, I put little marks on, and it just means that any tiny asymmetries cancel each other out. And there's our fake pommel peen, otherwise known as a rivet.
So beautiful.
Yeah.
I know I participated in this, but holy hell, your finishing work is so gorgeous.
So basically, the quick way is glue it together.
Right.
And resin glues are quite strong enough to do this job because it's not going to be put under a lot of stress. And yeah, of course, we end up with a new dagger, of course.
Right, it's brand new and it's shiny,
Yes,
and we want it to have a little history.
Yeah, yeah. And it's also, we don't want the cut from the hero dagger to the urethane stunt daggers to be too obvious.
Right,
So-
and the urethane can't get quite the super shiny.
No, no. And the way this reflects too is totally different from paint surfaces. So
Right.
normally you can get away with cutting from one to the other. You just about never get away with having them side by side though.
So then it's incumbent on us to weather this a bit.
Yeah. Maybe we do a bit of weathering on the bronze bits in particular
Okay.
before we put it together.
You mean like
that's
some patinas?
or little chop marks, hammer marks, things like that.
I'm totally interested to see how you take a blade and take a knife and
Yeah.
make it look old.
The blade itself is actually the harder bit because the aging techniques I use involve acids and fruit pulp and salt and things, and then it takes time. And then I repeat and repeat and repeat to get this layered aged effect and then cut it back until it looks right. So, and that leaves that sort of old steel look of fine pitting with a bit of greying on the surface.
Oh wow, okay.
Yeah. That's going to be more awkward. We might have to rely on a paint effect for the blade to dull
Okay.
that back. The nice thing, of course, is that at the end of the job, you can clean it all off and you'll have a shiny blade again.
I may not though. I may just like
Okay.
keep it with the
Yep.
story of its aging.
Yeah.
I love
But these, we can knock about a little bit. The grip is already there. It's got cracking and other marks on it. Oh, of course, the other thing is now it fits the scabbard. It may not be like that on the shot anyway,
Yeah.
but later on you can keep it in the scabbard if you want.
That's beautiful. Okay, so,
I guess
let's start
knock
weathering.
these around a bit. So I'll just grab a couple of tools
Okay.
and we can just take it as far as you want to. So any sort of tool that will make a mark can be useful. So we want to get some general scuffing, some dings, some particularly on corners, some little marks on there.
Okay.
And we go further than you would get actual aging on an original piece because the camera doesn't pick up some of this.
So you need to be more obvious about it. More.
Yeah, so we actually take it a little too far, and yeah, hopefully then it matches a bit more what we have. So we've got things like a little chisel. It's going to be hard to pick this up on camera, but things like a little chop mark,
Okay.
scratches.
I'm
Using the bits of the hammer to just create general marks. Straight away you can see the surface is already
yeah.
less beautiful, but a bit more character.
betraying its age and its
Yeah.
history. You have some experience. I'd love to hear your thought process in thinking. Like, do you actually think of the stories about the kind of things that
how
encounter?
things like this have been used. So with a dagger, of course, the blade's normally in the scabbard, so blades might rust, but they generally don't get knocked around unless they've been abused, like levering things or trying to stop a sword blade with a dagger and then you get a big chip out of the edge or something like that.
Right.
But it's the hilt that will get the damage because it's always exposed. So things like pommels would bang against hard things, so these things like these edges would get nicks,
Right.
these scratches there, less marks there probably because that's a little protected. But the top of that would take a bit more damage. This would get a bit on the ends because again it's continually knocking against things. Scratches across there from like rubbing against doorways and things like that. The grip would take damage, but we've already got damage there.
Yeah.
So that's like old wood that's got cracks in it. So that's sufficient. It's also plastic, so if we do anything on it, it has to get painted again.
Right. Oh, I see. Yes.
So it's actually a printed grey plastic, so best to leave that alone.
That one's just fine.
Yeah. Oh, and another thing is getting coarse sandpaper, and you can simulate, not so much on this, but on mild steels, by hammering very coarse sandpaper against steel or aluminium, you can get little tiny pitting.
Oh.
Particularly on aluminium. Steel's much harder to work with, but yeah, with aluminium stunt blades, it's a way of getting a bit of subtle aging in there.
Oh, neat. That hadn't occurred to me.
This can all be done pretty quickly too. So yeah, it's definitely, it's adding years every second. So I started off by hitting that with the ball, and that actually looks a little bit artificial.
Yeah.
What I did on this side with more of this sort of scuffing, but getting a little ding and a scuff, is actually more like what I think would work.
Yeah.
Now it looks a little extreme, but as soon as you start moving one of these, as any sort of prop, you start moving it around and most of the stuff disappears.
Right, yeah.
Unless it's a real close-up and everything is still, you don't appreciate most of this. I can even put that back on a linear and just smooth a bit of that off to make it less new looking.
Right. Oh, yeah.
That's a slightly more rounded edge on that. So it's not quite such an abrupt chop mark. I might even add some of that back on the crossguard as well.
And you're just using the weight of the tool itself too?
Yep. Bronze is not very hard, and it's a matter of making it look like it's not cartoony. Like the matching things like urethanes. Urethanes, when they do aging, they tend to overdo things like little cut marks and things like that because it's urethane. It's so soft. They don't appreciate quite often on a harder piece that to do that sort of damage, you're virtually sticking it in a press or something
right.
to get that level of damage on steel and bronze and some of the older materials. So I think just a minute or two with a Scotch-Brite belt.
So it's just not taking off any material, it's more just like...
when you put a chop mark, get this little ridge that forms.
Right.
So this is just removing those ridges, and even if you don't really see them, it's quite amazing the difference it makes to the way it feels.
Yeah.
Of course, now it's getting really, really shiny too.
Yeah.
Which
We'll have to deal with that.
Because it's warm, I suspect the glue's going to go off pretty quick.
Okay.
So it's 5-minute epoxy, but I think we'll be lucky if we have 5 minutes. So the best way is to do it one component at a time. That's the safe way.
And I love that smell of the epoxy.
Yes. Dribble a little bit down inside here so that where I've got these little landings, there'll be enough glue that it's sure to squeeze out. And then it gets messy. Because as always, it goes everywhere.
Oh, wow.
There we go. Of course, while it's still liquid...
What is this stuff?
Oh, that's just methylated spirits.
Oh, okay.
Yeah, I found it's the most user-friendly solvent you can get.
What would be the, is that denatured alcohol?
Yep, that's the other one. But methylated spirits is cheap.
Oh, okay, they're not the same thing.
I think they're basically the same thing, but denatured alcohol is probably a bit more pure.
I see, okay.
There is. But the classic story I heard was, some old story about a wagon repair job, and the wheelwright did this thing, and somebody else said to him, "But they'll never see that. Why are you taking so much care?" And he replied, "I know it's there."
Yes.
Okay, check everything matches nicely, so that's all looking good. And the glue is still liquid. I won't risk using that because, sod's law. You're halfway through using the glue on the second lot and it goes,
Right, yeah.
So, new batch. And what I do, because this is tapered, I put a coating on the tang, and if I do it really, really carefully, the grip doesn't scrape it all the way up. And then everything just tightens up and squeezes out the last of the glue just as it's getting into final position. I probably can't use methylated spirits because I'm not sure what
they would do to this.
dissolves the paint. So
Right.
I'll play this one a bit more carefully and just do it with wipe it off with a dry rag. And I push the glue up towards the top because, of course, this is going to push it all down.
Right.
Okay, this is going to be quicker than I thought, because I thought we were going to have to wait for each lot of glue to set, but that's working out very well.
That's really nice.
And I think I will use the same glue on the pommel because it that went on so quickly.
Yeah.
Final scrapes. Wiggling it like that, hopefully
Working the glue into
lets the glue go up into the pommel. Since I know the pommel's still not going to do anything, I just go around doing that.
Right.
And hopefully it gets rid of that bit of shine that the epoxy tends to get. So I might as well leave the glue on there because it's going to help the aging. So yeah, we just lean that up against something and wait.
All right.
Here we are, finished and all the glue's set.
That is beautiful. It's perfect.
Yep, great.
Thank you, Peter. Thanks for letting me participate in this.
Always glad to help.
Go. Now we're off to some painting and more weathering.
Yep, dull that down a bit. Awesome. Look a little bit less new and shiny and you're ready.
It's gorgeous. All right, Dottie, I see we've got some stunt daggers here.
Yep.
They are different.
Density, yeah, so you can...
Yeah, that's awesome. They look totally badass and scary, but they're rubber and... Oh.
Yeah, so that one is really rubbery, so you can go and stab someone with that without damaging them too much, so yeah.
But
we try and, make them look the same. And I guess that's what we're trying to do, eh?
Well,
Make it look
I
like your
brought the one from Peter Lyon's place, and it's a little bit new and shiny.
Yeah.
So I need your help beating the crap out of it and bringing it
try and
down
make
to
it look
looking
like
more like
this.
these guys. I know formally it's got some slight differences, but I think that once we get it to the paint to look right, it's going to feel the same.
So I reckon we should start with an aging wash. Do you want to do this?
Oh, sure, sure.
Do this, eh?
I will take your instruction.
So this is just like an acrylic wash. I'll give you a smaller brush maybe.
Oh, I could deal with that.
You deal with a big one?
Absolutely.
And what I did on these one, I brushed it on the whole thing and then dabbed it up.
Yeah.
Shame.
We'll deal with the blade later, or shall we?
Yeah, you can go down it if you want, but you don't have anywhere to hold then.
All right.
And then I usually just dab it off to a level, so leave some of it, because then when it dries, you've got like a pattern already made for you, dabbing it off like slightly. You can see already the colour is...
Yeah, yeah. I love a wash.
It's so hot in here, it dries fairly quickly, yeah.
Yeah, I know.
Yeah, and then it should sit in the detail like it does on here, and see it's slowly getting the same way. Water.
Yeah.
And your rag or...
Oh yeah, there you go. Perfect.
There we go.
I love the brown of the handle. Oh, now I've made a clean spot.
Always add some more. On the plastics.
That's a thing for you, isn't it? Right? Like each of these materials, rubber, plastic,
yeah,
metal, they all
react
take the paint differently.
Yeah, so you have to try and figure out methods where you can get it all matching as closely as possible, because
Oh, look at that! I mean, yeah.
it's not going to want to stick to this. Quite high polished, that metal. It's probably not going to want to stick so well to that.
Come on. Well, the other question I have sometimes. Yeah, how do you want to bring down the blade? It's also
On these ones, I just put it in the detail because it's got little dings and stuff in the blade, but I don't think this one does it?
The problem is because it's spring steel and we hardened it, so it's not going to take any
It's not going to do anything. So I sometimes just put the aging on in a stipple-y kind of manner like this. I'll just do a little section. And then I dab it off. And then...
Oh, that matches right away.
And then maybe just lightly. I use a lot of saliva, sorry, I
Yeah.
just put saliva on you. But, you know, then you suddenly have a little bit of aging
Yeah, it's
in
killed
there.
some of that reflectivity.
Yep.
Totally. Well, and what do you think? Do I want to?
Yeah, I want to add some more up here.
Yeah.
I'm just knocking it back so it's kind of, it's still there, but it's subtle. And for, you know, when we do aging on things like this, it usually sits in the recesses, so we don't actually have to, you know, and it dries.
Right,
you know, when you
right.
get on your clothes, it sticks. And if it sits in the recesses as well, it will stick, so you can get that, you know, the gloss and the satin and the, you know, the contrast in between the different, you know, sheens, which also makes it look more believable than if it's just shiny all over.
Yeah,
That's what I think anyway.
Whenever it looks too new.
Yeah. But leave it to dry and then we'll buff it back.
Okay.
And I also wanted to use some of this. So
All right. So what is this technique you're about to implement
this
here?
is some wax. It's actually for leather, and we add a little bit
That's
of...
a leather wax finish, right? Okay.
And then we put the
A little fuller's earth.
fuller's earth in it, and it turns it into a dust that we can put in the cracks.
Ah.
So hopefully I've put enough. And that's the same, just brush it on where you want it, put it in the detail. Maybe a little bit around, you know, you wouldn't be able to clean it.
And it's just a slightly lighter value dust and dirt that goes in the cracks.
And when it dries, it goes like real dusty. It's dried really quickly. It takes a while, and then it goes, you can see it goes lighter when you...
And my technique for weathering is I make a first pass, it's terrible, and as I'm removing it and angry at myself, it looks much better.
There you go. That works too. So you see how, do the other side.
All right. Just adding this.
Because, you know, when it's on the grip, it would be, you know, someone would be holding it, so it would only sit in the recesses and wear.
Right, right. They'd be polishing it with use.
Yeah.
Oh, that's really lovely. That's really great. I mean, that all of a sudden feels like an old, you know, skin scales in there. I love looking at things just that are naturally weathered, like stairs in a train station that are slightly lower from all the people walking on them.
Yeah, all of that. It depends on what you're doing at the time, because in here we paint like everything that goes through the workshop comes through this department. So, you know, if you paint skin, I keep staring at people's faces, or if it's, you know, you just kind of, you know, with visual, it's a visual job, so you keep staring at, you know, all these kind of things when you,
I did
do it as a
some
job.
buildings falling apart for a film, and on my commute to work, there was a building being built.
Oh, yeah.
And forever after, think of that building as the one that helped me be inspired on how what's inside a building once it's falling to pieces.
Yeah, real life is always a great help, you know.
It's like your own, it's your Fuller's Earth Rub and Buff.
Yeah, but it doesn't it doesn't exist. Just make your own one. There you go.
That's
Look at that.
great. That
And someone would have had that for a while, you know, using it every day, and
yeah. Would have their. No, weathering is my favorite part of every
it is. It
project.
kind of adds that history to,
It ties it all together.
and also makes it easier as well, because when you do really clean paint jobs, you know, you can't get away with anything. Everything has to be perfect. So with these ones, you can kind of hide some sins. And
Yeah.
So
The worst job I ever had to do was a museum quality miniature truck replica. And the paint job just was 2 weeks of failure.
oh no!
The client sent it
So it
back.
was no aging at all. It was all like no.
Had to be pristine.
Yeah.
It was the
that
worst.
makes it-
and it was
makes
a
it really-
scratch-built Model A Ford truck, and awful.
But then this is much better. There we go. Reckon?
Awesome, thank you. Well,
You're welcome.
We'll get the hero to match these, and then we'll be ready for stabbing some monsters.
Yeah.